Hi class, welcome to lesson 6. By the end of this lesson, you should be able to convert between Celsius and Kelvin temperature scales, evaluate accuracy by calculating percent error, and use reference table S to determine the state of matter of any element at any given temperature. Let's get started. Temperature is the measure of the average kinetic energy of a substance. When particles are moving slowly, they will have a lower temperature, and as particles speed up, they may have a higher temperature. We know that as we increase temperature, we are often able to change the phase of matter from solid to liquid to gas. That being said, a solid at a temperature of, let's say, 5 degrees Celsius has less motion than a solid at a temperature of 20 degrees Celsius. So as we increase temperature, we always increase average kinetic energy. Temperature does not depend on the size or amount of matter. So you can have substances with very different masses that have exactly the same temperature. Human body temperature is approximately 37 degrees Celsius. This temperature is found in babies and in adults. There are 3 major temperature scales. All temperature scales are based on the relationship between the freezing point of water and the boiling point of water. We will not use Fahrenheit in science class, so we're going to pay attention instead to the Kelvin and the Celsius scales. It is very important that you memorize that on the Celsius scale, the freezing point or melting point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. Any item with a temperature less than 0 degrees Celsius will have a negative temperature. Now, Kelvin scale is made so that there are absolutely no negative numbers. So on the Kelvin scale, water freezes at 273 Kelvin and water boils at 373 Kelvin. Absolute zero or 0 Kelvin is a theoretical point when all molecular motion stops. There are no negative numbers on the Kelvin scale. A 5-degree difference on the Kelvin scale is exactly the same as a 5-degree difference on the Celsius scale. Notice here that there are 100 degrees between the freezing point of water and the boiling point of water on both the Kelvin and the Celsius scales. Let's see if we can solve this problem together. When converting from Kelvin to Celsius, we will want to use the equation found on reference table T. There's no need to memorize this equation as it's found on reference table T. But since this is the focus of our lesson today, make sure you write this equation down in your notes. In this example, we are looking for the Celsius temperature when the Kelvin temperature is 150. So when we substitute into this problem, notice that we have shown the equation, the correct substitution, and then we will use algebra to solve. So the Celsius value is negative 123 degrees Celsius. So by now, you should be able to use the equation on reference table T to convert between Kelvin and Celsius temperature. So the last thing that you have to do that is related to temperature is Determine the state of matter of a substance at any given temperature. You know that as you increase temperature, matter can change from solid to liquid to gas. But the physical property of melting point and boiling point are different for each of the elements. So the temperature in which we have those substances in the various states of matter can be different. For instance, at room temperature, the air is a gas, even though it has the same average kinetic energy as water, which is a liquid, which has the same kinetic energy as our student desk, which are solid. So they have the same average kinetic energy, but because they are different substances, they have different properties, and they have different states of matter at that one temperature. In Regents chemistry, we are often asked to determine the state of matter of a substance at STP. So here you can see STP. STP stands for standard temperature and pressure. And there are exact temperatures and pressure that are associated with STP, but you do not need to memorize them. They are found on the very front of your reference table in reference table A. Now, in order to find the state of matter at STP, you have to find the temperature of STP in Kelvin. The reason why we need Kelvin is when we look here, notice that the melting point and the boiling point on reference table S, these physical constants are given in Kelvin. So we have to make sure that we're comparing the same unit. So we know that if the given temperature comes before the melting point, then the substance has not melted and it will be a solid at STP. If the substance has STP or 273 Kelvin fall between the melting point and boiling point, then the substance will be a liquid. That's because the substance has already melted but has not yet boiled. And if STP, which again is 273, comes after both the melting point and the boiling point, it will be a substance that is a gas at that temperature because it is both melted and boiled. Let's see if we can work through some examples. So potassium is element number 19. So we look here on element number 19, and we're going to put in STP, which is 273, in a number line with its melting point and its boiling point. So its melting point is 337, and its boiling point is 1032. So the number 273 comes before both of those numbers. So you notice our number line is going and increasing. 273, 337, 1032. So since this comes before, potassium at STP is actually a solid. Now let's try fluorine, element number 9. So when we look at fluorine, which is element number 9, it has a very low melting point of 53 and a very low boiling point of 83. So the number 273 falls after these numbers. Again, we're making a number line. So 53, 83, 273. Since it comes after, fluorine is a gas at STP. Now let's try bromine. Bromine is element number 35. When we look at bromine, its melting point is 266 and its boiling point is 332. The number 273 falls between these values. So when it falls between, you will have a liquid. Now, STP is a very important number in chemistry. A lot of the physical properties that we see here on reference table S are determined at STP, but we know that chemistry could happen at any temperature. So let's see what we'll do if they give us a temperature other than STP. So here, they ask you to determine the state of matter at 35 degrees Celsius. The first thing to note is that again, here on reference table S, the temperatures are in Kelvin. So the first thing you need to do is convert from Celsius to Kelvin. So you can see that I've done my conversion and I've come up with 308 Kelvin. So if I want to know the state of matter of sodium, element number 11, at 308, I'm going to take the number 308 and put it in a number line between its melting point and boiling point. So 308 comes before its melting point, making sodium a solid at this temperature. Now let's try argon. Argon is element number 18. Argon has a very low melting point and a very low freezing point. So the number 308 falls after both of these numbers. Again, look at the numbers and make sure that they are in increasing order. 84, 87, 308. So 308 coming after those makes argon a gas at 35 degrees Celsius. Lastly, let's look at gallium. Gallium is really interesting because at STP, gallium is actually a solid. But at 308 degrees Kelvin, that number falls between its melting point and its boiling point. So at this temperature, 35 degrees Celsius, gallium is a liquid. So by now, you should be able to use reference table S to determine the state of matter of any element at any given temperature. This concludes lesson number 6. Make sure you've taken good notes. Write down any questions you have and bring them to class. We'll discuss them. Make sure you complete your homework on Google Classroom, and don't forget to put your reference table and calculator back in your backpack so that you will be prepared for class. I'll see you soon.